Sound on Mars is slow. High frequencies fade away, leaving everything flat and heavy. That's because Martian atmosphere is made of carbon dioxide and is over 100 times thinner than the atmosphere of Earth, so sound on Mars moves like it's underwater. This planet once had real water too. The whole basin that is on the screen right now was once a lake, and these rocks were its floor. Their smooth rounded edges could only form from years of water erosion. Perseverance captured all these images shaped exactly like stones from a mountain stream. Jezero used to be a lake, but where did all that water go, and when did it disappear? Sun didn't destroy Mars's water, it just pushed it away, atom by atom. Solar radiation breaks water molecules apart, letting hydrogen drift into space. NASA's MAVEN spacecraft has been measuring these atmospheric laws in real time since 2014. It found that the red planet loses about 100 grams of atmosphere to space every second. What the Sun started, it never finished. Mars is still disappearing. But what does a vanishing planet actually look like, up close? Zoom in and Mars looks less like a planet, but more like a fossil. A fossil is a record, not a living thing, and that's exactly what Mars has become. Curiosity found mineral deposits, formed only where standing water once sat, and they are still there, unchanged. Nothing on Earth has survived unchanged that long. Mars has. Some regions of red planet stayed unchanged longer than complex life has existed on Earth. Earth's oceans and rivers erased landscapes in millions of years. Mars has neither. The Grand Canyon took just 5 million years to form, and it's still changing today. Mars's ancient shorelines look exactly the way they did when the water disappeared. Same starting point, same age, but two completely different endings. If Mars kept its rocks perfectly intact, could it have kept life intact too? Martian lake beds contain the same conditions where microbial life first appeared on Earth. Perseverance found rock formations in Jezero with the same layered texture as Earth's oldest microbial fossils. If the texture matches, maybe the story matches too. NASA did the only thing you can do with a question like that. They went looking. They found a pattern that life usually leaves behind. In September 2024, Perseverance drilled into a rock called Cheyava Falls and found exactly that kind of pattern. The rock showed dozens of small dark spots nicknamed Leopard spots scattered across its surface. The rover sealed the sample inside a titanium tube, waiting for a future mission to bring it back to Earth. If those spots turn out to be biological, it would mean that Earth wasn't the only place life ever began. If life started twice in one solar system, the odds of it happening elsewhere in the galaxy skyrocket. The Milky Way, for example, alone contains an estimated 100 billion stars, many with their own planets. Scientists estimate there could be billions of Earth-like planets in our galaxy alone. One answer from one rock could change how humanity sees its place in the universe. Some scientists are not excited about this sample, they are worried about it. NASA itself classifies sample return missions under strict planetary protection protocols precisely because of this risk. This is the most extensive planetary protection protocol ever designed for a single space mission in history. NASA is not hoping for the best, it's preparing for the most consequential outcome imaginable. That's the weight one sample can carry when nobody knows what's inside it. This is not the first time humanity has faced this exact uncertainty. In 1969, NASA quarantined the Apollo for 3 weeks just in case the moon carried something back with them. The astronauts remained in quarantine for a total of 21 days before doctors declared them free of any lunar contamination. The moon was the easy version of this question. Mars is the one scientists have actually been afraid of. So what happens next depends entirely on decisions being made right now. On Earth, scientists are still debating whether the sample should be studied in orbit before it's ever allowed to touch Earth's surface. Unresolved debate is one of the key reasons the mission's return date keeps shifting further into the future. And every delay is really just humanity asking itself the same question again and again. Are we ready?